So yeah, thank you so much, first of all, joining this session. As I mentioned on this page, already you can find this page in the meeting invite as well. This page is going to give you some information regarding how to approach especially out-of-memory errors or full GCs that's happening in JVM while we are working on the memory issues. Of course, that's not only the way that we fix all out-of-memory errors, but I think, at least based on my experiences that I worked recently, or since I joined Atlassian, that's a really important one and very first thing to check when you are working on a ticket and then the customer is complaining about memory pressure on JVM, or maybe JVM crashes due to insufficient physical memory on the server. Yeah, that will be the first thing maybe for you to check if there is something to do in this way or not. So I know that most of you know how GC works, at least to check the logs, and then you can understand when it happened, a full GC or a minor GC happened, and then how much was the heap size before the GC and then after the GC. But I will try to give you again some basic information regarding what kind of regions we have in the heap size, in the JVM heap region, sorry. Also, what happens during a minor GC or during an allocation when JVM needs to do a minor GC and when it needs to perform a full GC. And at the end, of course, we are going to discuss on an example that I recently worked on it, how to approach for such problems when you are working on a ticket. Please feel free to interrupt me, to ask any questions, or if something is not clear for you. So I will try to explain. Also, we have some other experienced engineers on the call. They can also help me if I am stuck to explain you something. They can share their experiences as well. So yes, I think we can start. You know that we are sometimes working on some memory issues while we are working with the customers, and then it may happen they had an sorry, still recovering from COVID. So you know that they can raise a ticket to us, and they say that we had a problem, and then when you did your investigation, you saw that there are full GCs. Not only full it's not only the problem you need to address when working on an out-of-memory issue, but sometimes you need to deal with the full GCs as well. So it may happen that the customer has all the settings for heap dump on out-of-memory error, but still there is no out-of-memory triggered by JVM, but full GCs are happening. And then let's say you ask them for some issues like setting the heap parameters for heap dump on full GC, or a heap dump is generated automatically by JVM. You analyze it, and then you address the issue. You saw who is the most memory consumer in the heap, and then you address it to a bug. Then you resolve the issue. As you know that it's not always happening like that. So the customer has that memory pressure problem. You do your analysis, and then basically what we do, the very first thing we ask them to increase the heap size. But in most of the cases, maybe it's helpful, but still, maybe it's good to understand if it's really needed, or we are just mitigating the issue, you know. And then the approach here can be that increase the heap size, or at least decrease and see, and then let the JVM to, let's say, generate a heap dump. Then we can analyze it and to see that who is the most memory consumer in heap size. As I mentioned on this page, it's not always easy to tell the customer that let's increase the heap size, because it can be like maybe the customer doesn't have sufficient physical memory on the server, or you know that even you tell them to increase the heap size, they can say, but why? Please explain it to me. So we will find this information, at least an important part of this explanation during this training. Another one is sometimes the customer may have their heap size is 31 gigabyte, and then we ask them to increase it to, for example, more than 31, but there is a limitation in Java. I attach a link there. Why the 35 gigabyte is just an example. I think based on my calculations, it's like if you want to go over 31 gigabyte, you need to set heap size with more than 45 gigabytes. So in that region, the allocation in the heap is changing, and then you will find more information in that blog post. I strongly recommend all of you, if you haven't seen that one. So it's going to help you a lot to understand what's happening, why why, for example, setting the heap size 35 gigabyte is actually setting the heap size less than 31 gigabyte, 22 gigabytes, sorry. So yes, we have some limitations, as I said. And then after taking a look at this, so we need to understand if we really need to increase the heap, or and what should be the size. I mean, let's see, the customers maybe heap size is 20 gigabyte. So is it good to set directly to 31 gigabyte, 25 gigabyte, or 50 gigabyte? We need to define and understand why, or what should be the optimum value. Of course, it's not always easy to say, but analyzing the GC, by analyzing the GC logs, we can understand it. That's the main topic of this training. But before that, first of all, I want to show you the fields that we have in the JVM. Then after that, we will talk about when a minor GC is needed, when full GC is needed. And after that, we will focus on this topic. Any questions so far? At least the purpose of this training. Okay. So
I do have one.
Yes.
I mean, it would be nice just to say what GC is there for, you know, in general.
Yeah, I will give this information right now. So first of all, I want to talk about the heap regions. Then we will talk about when it is needed and why, of course. Okay. So in this on this picture, you can see that this is the JVM memory allocation. The heap memory that you see is the mainly reserved for our application threads. So when your application is started by the admin, and then the requests are started to come to the application, and memory allocation is, let's say, done by application threads, and then the users are doing their tasks, and then when they finish what they do, that memory becomes a garbage. So that's why we call this a garbage collection, you know, because we have a limited resource on the server, and then there should be always a recycling. So this recycling is called as a garbage collection. Someone used some resources and then finished what he or she needs to do, and then it becomes garbage. Then this garbage is collected and becomes available for the new threads, so new requests by the users. So we have a heap memory, we have metaspace, stack, and code cache. So I already explained here what each of these fields is used, but I mainly want to focus on the heap memory. Okay, on the heap memory, we have we call basically heap fields in two different fields. Like one of them is the young generation, another one is old generation. So young generation has three different spaces. One of them is add-on space, another one is survivor 0 and survivor 1, or you can call it survivor 1 or survivor 2. and tenured space we have. So this is in this add-on space. It's the space when the first allocation is done. So you started Jira, and then it started to serve the requests, and then you send the first request. The memory allocation is done always for the first time in add-on space. So you get amount of memory that your application thread needs. Then another request comes, and it also makes another allocation, and each thread reaches out to application. It goes to the add-on space, and then gets some memory from this space. So of course, this space is limited, right? And then this space is, by the way, this space are defined by JVM itself. So let's say you set your heap size to 20 gigabyte, and our garbage collection algorithm is G1 collector in Jira by default. So G1 GC divides heap into add-on space, survivor spaces, and tenured space based on its algorithm. So this is, we don't need to do anything additionally by default, of course. So if you want to, of course, you can still define what can be the add-on space size, what can be the survivor space sizes, and then also your tenured space as well. But as I said, that by default, when everything is fine, you don't need to do anything. In some cases, very complex cases, you may need to tune your heap size by setting each field size with some specific JVM parameters into your startup options, you know. So as you know that, as I said, that when the first request or the requests are made, the allocation is happening in the add-on space first, okay? So nothing happens regarding minor GC or full GC until there is no sufficient space in add-on field. So you make some allocations here, but it may happen, as I said, that let's say your heap size is 20 gigabyte, and then add-on space is set by G1 GC, let's say 10 gigabyte, okay? So when there is no enough space, and then all this 10 gigabyte is used, some of them is garbage, some of them are still active objects, then a minor GC is triggered by JVM. So how does minor GC works? When I explained it here, as I said, that initially the survivor spaces and then the tenure space, old generation size is empty. And then if JVM is not able to get any memory from add-on space from here, then it initiates the minor GC. So what happens during the minor GC? The unreachable objects means that which are used and then left as garbage. Okay, and then by JVM, these are collected, these are marked as they are going to be collected and then become available again for the new requests. So during the minor GC, I told you that we have two different survivor space. One of them is survivor 1 and then survivor 2. During minor GCs, one of these spaces is marked as 2 space, which means that we are going to move reachable objects into this space so that we can perform a minor garbage collection. So we have, as I said, add-on space is full, but 10 gigabyte. For example, 5 gigabyte of add-on space is live objects, and then 8 gigabyte is unreachable objects, garbage. 2 gigabyte is available objects. And then JVM decided to, someone came and then tried to make an allocation more than 2 gigabyte. And there is no enough space in the add-on space because the available memory there is 2 gigabyte. But more than 2 GB is needed. Then a minor GC is triggered. What is done here? JVM take all these available objects and put them into the survivor space, one of the survivors. So this space is called as two space. So let's say we initially did, JVM initially decided to move all active space in the Eden space to the S1. So, sorry, S0. S1 is always empty, I mean, for now, of course. So this is the first minor GC. We moved active objects to S0 and then collected unreachable objects. So this is called the first minor GC. When the second one is happening and the application started to do other operations, and then the Eden space is again, let's say almost full, and then JVM again does the same, but what it does now, it has some live objects in Eden space, and also you know that we moved some live objects in S0 as well, right? So it moves live objects from Eden space and S space to S1, and then do another garbage collection, minor one. So as you see that one of the survivor space is always empty, so that we can move live objects between these two survivor spaces. So this is called minor GC. Any questions so far?
I didn't quite get the survivor space. What's the role of the survivor space in all this, and why there's two of them?
Sure. So as I said that it doesn't matter who comes to the application, but all the allocations are made in Eden space, right? You wanted to create an issue, and then this requires an amount of memory. And then, like, for example, you decided to create 1,000 issues at the same time, and then you did some allocations at the same time. Let's say you got all the available memory from Eden space.
I guess the question that I have more specifically would be, what qualifies as a reason to promote an object to survivor space, and to which survivor space specifically?
It doesn't matter. I mean, you can start. I mean, JVM can start to use one of them only. As I said, we have two. One of them is always empty, so that we can move live objects to other one to perform the minor GC.
Okay, I see. It's used as a swap space.
Exactly. So you move from S1 to S0 to S1, perform minor GC. Another minor GC is needed. Then move all the live objects from Eden and S1 to S0 again. Do minor GC again from Eden space to S0, live objects to S1. So you do this between always, like go to other space. Okay, minor GC is needed. Okay, move another space, then collect others, move other space, collect others, collect dead objects. And we do this, there is a max tenoring threshold parameter, which is defined by JVM itself. It's by default, it's 15. So I didn't check if we can set it like, if we need. So when there are two different cases, when a full GC is needed. One of them is when, okay, so this was the one thing, and then it's going to be done until we do this for 15 times, okay? The second thing is that the objects, when we are doing this move between each survivor space, okay? So there are some, actually, each these spaces, fields, sorry, they are, they have blocks, right? For example, we have this heap size like 20 gigabyte, and then JVM divides each and whole heap into the blocks, right? And then by default, it tries to have 2048 blocks. Let's say we have 20 gigabyte, and then if you divide 20 gigabyte to 2048, you will see each block size, okay? And then each allocation is made as the blocks. Like, for example, the block size is 8 megabyte. okay, then you need, for example, 64 gigabyte allocation for one of your requests. And that means that you are going to allocate each block for your allocations. I will explain more in the upcoming example, but the allocations are made by these blocks. So you are doing minor GCs, but sometimes when you are doing minor GCs and moving your objects to S0 or S1, it depends on the phase. Sometimes some of your objects, live objects, are not able to fit into survivor 1 or survivor 0 space because size is limited. As you know that we also have tenured space. So when you are moving your objects between each survivor space, and if it is not available, the size is too big, then you move all these live objects to tenured space, your old generation. So this happens during the minor GC. Any questions so far? So because this is a bit complicated, it can be a bit complicated for some of us, and I don't want to miss that point.
I have one observation.
Yes.
Just to take it simple, I think that is the hidden space is reserved for the new incoming object. The lifetime is very short, and then during the time it will get promoted to the other areas, and in the meantime all the ones that are actually not needed anymore, they will be cleaned up. Exactly. And then you get from the hidden to S1 and S0, and then if it is still need more time, it will go to the next tenured space.
Yes.
And every time the not needed one will be cleaned up, and then you are gaining some memory, and that is how it works in general.
Exactly. This is what you say that needed, which is not needed to be cleaned up. It's called minor GC, as I said.
Right. Yeah.
So which you said that it's going to be moved to tenured space means that it's not fit into the two space. I mean, two space means that the space that we are going to move live objects during the minor GC, okay? We are still at the minor GC phase.
Right, yeah.
So sometimes it's not easy to fit all of them into the survivor space. Then what we do, we move them to the tenured space. So even, yes, tenured space is old generation and it also has some available fit, but means that it's not unlimited, right? So you are doing minor GCs, you are moving your live objects between S1 and S0, but sometimes it's full or not insufficient space there. You move to old space to tenured space. So this goes until JVM heap size is almost full. Then when it's full, what you do, you need a full GC, right? Then you stop application threads, please pause. I am going to perform a cleanup. So your hidden space is full, your live objects are not fit into S1, S0 or tenured space, it's also full. Now, still application threads are coming for new memory requests, but you're not able to give, but you still have a lot of garbages in the heap size. So what you do, you say, okay, wait, I'm going to perform a full GC, then you start the full GC here. Actually, this is how it happens. You do a lot of minor GCs, and then you move your objects to one of the survivor spaces, or when it doesn't fit, goes to the tenured space. Tenured space is full, and full GC is needed. So actually,
I think you're explaining the mechanics of it beautifully, but I think that there is one, you know, like the top-down idea that's missing here, which is the fact that most objects die young. And so the idea here is to have fewer full GCs, stop the world pauses as possible.
Yes. So
to have as many minor GC as possible. Yeah. Exactly.
So that's why G1 GC. That's why we don't do anything. What Stefano said that actually. So G1 GC is G1 GC aims to a low pause behavior, which means that there will be some pauses during the GCs, but end users shouldn't understand this because during each minor GC or full GC, application threads stops. Application threads stop. So if this pause time is big, then it's like when you are trying to create an issue, click on something and then it freezes, right, for a while. So for example, if this is during a minor GC, you may not understand why it paused a bit, because the target pause time is defined by G1 GC, and it's tried to be low, as much as low. So, but at the same time, there is another approach, the efficiency. I will try to show you something. 1 second. What is the efficiency? So this is, for example, one of the GC logs, okay? As you see that we have throughput here. So throughput tries to be, this is the target of G1 GC. Collect as much as dead objects during the minor GC or full GC. So in this example, as you see that JVM is almost 100% efficient. So when you are working on GC log analysis, this is one of the important things that you need to check. For example, the target pause time is by JVM during the minor GC is, let's say, less than 1 second. And JVM says that, okay, in this less than 1 second, I am going to collect 99.9% of the dead objects and make them available for the new requests. So this is the, yes, as I said, that as also Stefano, the target, that the aim of the JVM. But of course, during full GC, this pause time is, it depends on the application behavior as well. It depends how your heap size is big, because let's say you have a big house and then cleaning that big house takes 2 hours for someone. But if it is just one room, is a studio flat, it's going to take, for example, for you 15 minutes. So if your heap size is big, your pause time during the full GC is going to be bigger. If the heap size is small, then the time of pause that your users are going to feel during the full GC is going to be low compared to the 2 different heap sizes, big or small. So yes, this is how minor GC and then full GC works, and then when they are needed. And so I want to now talk about our main topic, actually. I told you that we have some memory issues. We ask customer if we are not able to identify after analyzing the heap size, heap dumps, we tell customer to increase the heap. Okay, this is mostly, sometimes, not mostly, a good approach to mitigate the issue, or we can resolve many tickets by asking them to increase. But there are 2 things to do. One question to ask ourselves. What should be the heap size? Okay, so now we are going to understand how to define the heap size in such cases. While you are working on such tickets, I would ask you to check in the GC logs. I will tell you. But before that, I want to talk about 2-space exhausted and then humongous allocations. You know that we defined the 2-space just while we were talking about minor GCs, right? 2-space is the space, one of the survivor spaces that you are going to move your live objects. Okay, and then 2-space exhausted means that this space is full and you are not able to move your some of your objects. That's why you are moving your objects to 10-root space. This is 2-space exhausted. And then humongous allocations. I will talk humongous allocations, but before that, I want to stop and ask if you have any questions so far. Okay, so humongous allocations. As you know that I told you while I was talking about the heap regions, basically each region has they have a lot of blocks, and these blocks are defined by JVM during the startup based on the heap size, of course. So when you set a heap size by XMS and XMX, JVM is going to divide itself into the equal small blocks. The minimum block size is 1 megabyte, and then maximum block size is currently it's 32 megabytes. So from 1 megabyte to 32 megabytes. Okay, so for example, if you set your heap size 20 gigabyte, you can just divide into around. JVM is going to divide itself, the heap size, into 2048 blocks. So by dividing your 20 gigabyte to 2028, you can find approximately each block size. So, and then when an allocation is requested, these blocks are being taken by the JVM threads. I go down. So as I said, that the region size can be from 1 megabyte up to 32 megabyte, and then the goal is to have no more than 2048 regions. But when you are setting a heap size, because if you multiply 32 megabyte to 2048, I think I need to check. Let me quickly calculate it, because it's not always possible to have around 2048 blocks, because if you set your heap size to higher value and then max block size is 30, region size is 32 megabytes. So I will quickly check. Okay, it's around 65 gigabytes. But sometimes you may need to increase your heap size as well. More than 65 gigabyte means that you will have more blocks. Yes, this is the base. So this is, yeah, Stefano.
Just quickly before we lose the where we were going at, what's a humongous location?
I'm going to tell about it, because before that I need to explain this one. Okay, so we need to know that JVM has blocks, and then this block size can be from 1 megabyte to 32 megabyte up to 32 megabyte. And then based on the 32 megabyte, and if JVM needs 2048 blocks, your heap size can be around maximum 35 gigabyte, but sometimes you can set more than 35 gigabyte as well. So it depends on, because it may happen that your application is really memory consumer. Then if you don't want to go more than 65 gigabyte, then you may need to talk with your developers and then tune your application in terms of memory consuming. So this is something you need to decide where to go to understand why your application is consuming a lot of memory, or if it is the way and they are not going to change anything, then they increase your heap size more than this. But of course, now we need to understand the humongous allocations. Okay, if you just go and check your local instances, and then after you start your JVM Jira process, you will see at the beginning of your GC logs such information. Okay, this shows a lot of parameters regarding the JVM heap size that you set, and then you will see this. Here, in this example, we can see that max heap size is 50 gigabytes. We can see here. So this is byte, and then when we convert it to gigabyte, is 50 gigabyte. And you know that we were talking about block sizes, right? So this block size is defined by G1 heap region size. Okay, so that's the main parameter when you are working on such issues and then asking customers to share a support zip file. The very first thing you need to check, what is the G1 heap region size, and then what is the heap size. Okay, these are important. You need to note these two parameters down. And of course, as I said, you can go and check your JVM arguments, and then for sure you will not see this. So we see this in the GC logs because this is calculated and set it by JVM itself. I told you here that based on the heap size that you set, each space size and then this G1 region, heap region size is defined by G1 GC automatically. So you don't need to do anything specifically, but you can still tune. So this is actually what we are going to check and do. We will, in this example, we will, if we have humongous allocations, we are going to work on this, on heap size and then G1 heap region size. So what is humongous allocation? Humongous allocation, you will see if you go and check your GC logs, and if a humongous allocation is done, you will see such entries, log entries, okay? Like G1 humongous allocation, and it's going to give you some information. Of course, it just shows you that as humongous allocation is happened, and of course, two space exhausted messages as well. But we are now going to focus on this humongous allocation part. Humongous allocation is, I will give you an example to make it more understandable. You try to create an issue in Jira, you create on issue create button, the thread is created and then went to the application code is executed, and then it said, okay, for this type of operation, I need 100 megabyte, okay? But for some objects, it said that I need 100 megabyte, and then it asks this amount of memory from the heap by blocks, okay? So it said that I need an object of 17 megabyte, okay, 17 megabyte. But we know that so 17 megabyte means that you need an amount of memory which is bigger than G1 heap region size. So you are not able to get easily. I mean, you request a size of memory, an amount of memory from the heap, which is actually bigger than your current G1 heap region size. For such cases, you will see an entry in the GC logs as G1 humongous allocation. This allocation is still being done, by the way, but you have this amount of memory, but it's humongous allocation, and this allocation is being done in the tenured space here from the old generation. So when you go and then check your GC logs and so humongous allocation, it's a problem actually. So, and when you see, of course, by default, it may not be, but when you have full GCs, regular full GCs, means that you are not allocating the memory efficiently because you have blocks, and then based on the Java's algorithm, to have a healthy allocation, your allocation for each block should be 50%, shouldn't be more than 50% of your G1 heap region size. So what is our G1 heap region size here in this example? It's 8 megabyte. Okay, so if it is 8 megabyte, and for a healthy allocation, if we think that if the application thread is asking more than 4 megabytes object, then this is going to be marked as humongous allocation. Okay, so 8 megabyte is our G1 G1 heap region size, and then the allocation request is 5 megabyte. Then this is a humongous allocation, and we will see it in the logs. We can easily see what you need to do. You have that problem. You see that you see a lot of full GCs, but there is no out of memory error maybe. But you can see, okay, your aim should be to remove this G1 humongous allocations from the GC logs. Then you need to understand what is the allocation, right? To do that, we have two different parameters here: print reference GC and then print adaptive size policy. When you set these two parameters and ask customer to set, then restart Jira and wait for a while. Let's say you ask them to enable these two parameters, and you waited for a couple of days, and then ask them to send a new support zip file. After the restart, you check the GC logs and you saw again G1 humongous allocation in the logs. Now, because of setting these two parameters, time to see the allocation amount. So after enabling these two parameters, if you go and check your GC logs, you will see such an entry when and humongous allocation is happening. It will show you something, and then here, as you see that, we have allocation request. Okay. Another.
Help.
Yes.
If I may, just so I understand the scenario correctly.
Yes.
Through the course of investigating what we think is a memory problem, we'll be looking through the GC logs, right?
Exactly.
Like something in GC viewer will trigger us like a full GC or something like that. Then
Yes.
we'll go look at the event, we'll follow it, and we'll say, oh, wow, look, there's like a whole bunch of humongous allocations. Or we'll see that there's many of them in the statistics in GC viewer, right? That's what we'll draw specifically our eyes here. But out of the box in our native, like with the settings that we have by default, we will only just see that the event happened. We won't actually see the size of it, which will be important because we need to map that back to the region size to understand, like, can we tune this in the application? Can we tune Java just a little bit, etc.?
Yes.
Okay.
Yes, exactly. So as you said, when you have such issue, and then go and first check if in the GC logs you see G1 humongous allocations. This is a very popular problem. I can say that. I mean, if you decide to ask customer to increase the heap size before that, of course, you need to understand which heap size should be for the customer to go. Before that, telling the customer to increase the heap size, or for example, increase from 20 to 30, first, please ask them to share a support zip file, check GC logs, and then especially grep for this G1 humongous allocation to see that if humongous allocations are happening or not, because we need to remove these allocations first to see that if it is to make the allocations efficient. After we saw G1 humongous allocations, of course, we don't see what is the allocation request, because we know if we check the GC logs at the beginning, we will see G1 heap region size, which is default defined by JVM, and you will see it based on this depends on your heap size. So maybe your heap size is 10 gigabytes, but so your G1 heap region size will be like 10 gigabytes divide 2048 blocks, as I mentioned here, and then you will see each size of the G1 region size. Okay.
Alp, one question. Let's say that is we have our heap size is 10 gigabyte and we go to 31. Is this space will change or not?
Yes, automatically by JVM.
Okay, then if we increase actually the heap size, then it may solve the problem.
It may, but it's important to understand
what
which is going to be your next heap size. So we are trying to understand this, and without seeing the allocation requests, here we only see G1 humongous allocation, right? We see, okay, there is a big allocation, and unhealthy allocation is done in JVM. But actually, we don't know what is the allocation size. If we know the allocation size, we know that it should be less than half of the G1 region size. Then, if we find the maximum allocation in the logs, then we can set G1 heap region size 2 times bigger than that allocation, and then solve the problem and define the heap size in this way. So, as I said, here we see G1 humongous allocation. We ask customer to enable these two parameters so that we can see the allocation size. They did, and then we ask them to share the new GC logs, and then in the GC logs, we saw allocation request here now. We have it. And then this is one of the examples. Of course, you need to check all the allocation requests and find the biggest one. Okay, you found it. And then in this example, I found it. It's like this bytes, which is around 15 megabytes. Okay, and we know that it should be less than half of the G1 heap region size. As I can go to maximum 32 megabytes for G1 heap region size, then half of the 32 is 16 megabytes. And if I set 32 megabyte G1 heap region size, then I will handle this allocation. And this allocation next time is not going to be humongous, and it will be a healthy allocation. Okay, so we found it as 15 megabyte. And then, as I said, if once you find the maximum allocation in the logs, you can define the new value G1 region size. So yeah, here we know that it was 8 megabyte, half of it is 4 megabyte, but our allocation is 15 megabyte. So 15 megabyte is bigger than 4 megabyte. Then what are we going to do? Rounded value of humongous allocations 2 times, and then multiplying it with the 2048 block size, then this is going to be your heap size to tell the customer to set. In this case, it's 16 megabyte because it's 15 megabyte allocation, and then 2048. Then, as you see, we ask them to XMS and XMX for the 64 megabyte because this is G1 heap region size 2 times the block size, and I divided into 1024 to make it gigabyte. It's around 64 gigabyte. Now, in this example, if the customer came with a memory problem, if I cannot find any problems in the heap size, I couldn't see anything, and then I check the GC logs, find out the humongous allocations, and I also check the heap region size. Then after enabling these 2 parameters, find out the allocation request, then double this allocation request, and then multiply it with 2048 blocks, and I found my heap size. Then I can explain it to the customer that this is the request. Yes, Pankaj.
Yeah, Alp, I just have one question. So you mentioned we look through all of the allocation sizes and try to figure out which is the largest one.
Yes.
And that particular size should be half of the heap region size, ideally.
Yes.
So in this case, since it was 15, we then, in order for it to be half of the heap region size, it should be 32 MB. So we are considering 32 MB as the block size of the region size. And then on that basis, we are then calculating what should be the expected, or what should be the heap size that they should set, which should be like 64 gigs in this particular example.
Yes.
Now, my question is, while we get this humongous heap allocation messages in the logs, should we look for a pattern? Because it could be one-off object that required that particular humongous allocation, and not necessarily that the JVM requires such a huge heap allocation. It could have been a one-off instance. It could have been some plugin or some code that required that particular allocation as a one-off instance. And if we are going by that calculation and then increasing the heap, obviously there are challenges wherein the customer needs to procure more resources if their RAM is not sufficient already. So they need to do that. Then they need to be able to make the changes on the heap and all of that. And if that is not really occurring multiple times over multiple GCs, then it might not be the ideal thing to do, because what if it was just one-off occurrence? So how do we know for sure that such an analysis would certainly help out with the problem?
Okay, good question. So as you see that I told you how to check if the humongous allocation is happening or not, or it's a one-time issue or not happening a lot. But so you will see like that. First of all, the customer will come with a problem like slow performance issue, or maybe Jira is sometimes performing slow, or we had a crash, and then you ask them to share the logs, then you checked and you saw your humongous allocations. Okay, then it's not like it may happen for one time, and then of course maybe if you're lucky, probably there will be a heap dump and you will analyze and find out. So we are not talking about that case. Okay, we are talking about a case when the customer is struggling a continuous memory pressure on JVM, and then you check and you see a lot of humongous allocations. Okay, not only one occurrence or two, something like that. A constant problem. We are talking about that one. Okay, because it may happen that it happened just once, and then you told them, okay, we see that at that time full memory, full GC is occurred, and full GC occurred. please continue observing. And they said that we had another outage today. We had another performance issue today, and it happens recently. Okay, we are going to focus in such cases, not for like it happened for once or twice, or when you check the memory GC logs, sorry, you saw just a few lines. Of course, it's not. In this example, I think I added here. Okay, here, if you go and check, you will see that it's a long story. David remembers it's T-Systems. So we work on that ticket together. And then, yes, the main problem was the heap, memory pressure on the heap. So we didn't just decided to increase directly from 31 gigabyte to 64 gigabyte. We did a lot of analysis. We saw many times they had many outages, and each outages we saw that there are hundreds of Humongous allocations.
Okay.
Okay. Yeah, sorry, Aziz, Mohammed is waiting. He was asking.
Okay.
Sorry.
Thank you. So it's almost the same point as Pankaj. So 15 megabytes for Java objects, I think it's huge. So unless the customer is streaming video or something, I'm not sure in which case do we have a 15 megabytes allocation. Also, I want to know, because as far as I know, it depends from the algorithm for garbage collection. That's how we define the block size. So G1 have its own block size by default. Parallel also have a block size. So I'm not sure where to check that information to see the default block size that corresponds to the algorithm. And also, why do we even raise the heap if the object size is 15 megabytes? So what could be a 15 megabytes, just for a real example?
Yeah, can you repeat
and
can you repeat your last question? Sorry.
Yeah, what is the object that makes what makes 15 megabytes object? So this is wrong. This should not even happen for us. Instead of raising, I think that I should look for what needs to be allocated as 15 megabytes. It most likely, and 99% of the cases, it's something wrong by the developer. Either it's a list or something structured that takes a lot of space. So why would we even raise the heap before knowing what is allocating 15 megabytes? But if you think that 15 megabytes object is okay, then forget about that question.
No, so it's a fair question, by the way. So in this example, I will tell you, maybe it may help us to understand in general and then our approach, okay? Here, we had a lot of difficulties while working with the customer, because we said that we have two different approaches here. One of them is decrease your heap size, reduce your heap size, so that let JVM to have an out of memory error so that we can see who is making these allocations. As you said, that 15 megabyte is quite big because it's a Humongous allocation, right? Because we see a lot of them in the logs. So we try to convince them to reduce the heap so that, because in this example, we didn't have any out of memory error. And as you know that mostly when we have an out of memory error, we can see who is making those allocations and we try to address the issue. But in that case, when it may happen in the future for you as well, you ask customer, let's reduce the heap size, because in this example, they were on 31 gigabyte and they thought, oh, this is quite big heap. And then we still don't understand why we have this problem. I said, look, it can be Jira itself, it can be a third-party plugin or something else, we don't know. In order to understand, we need a heap dump, or at least to set this parameter, heap dump on full GC. So when the full GC, right before the full GC, we can have a heap dump and understand, okay? So if you have such customers agree with you that they can reduce the heap size or set that parameter at least, which is a dangerous one, as you know, to do full GC before, heap dump before full GC, then it's easy to understand and address the issue and to see that why this Humongous allocation is happening. But in such cases, the customer doesn't agree to reduce the heap size. They also don't want to, they also don't have an out of memory error or a healthy heap dump to see and analyze. then you can recommend them, okay, look, I understand that you don't want to reduce, you don't have heaps, and then for us, we can only increase the heap. They say, okay, we can do that. Okay, this is up to you. I mean, you need to convince them. If you go them with some evidences, for sure they will accept to reduce the heap or increase the heap. It depends on the. So if here our purpose is to show them if they agree with heap increases, what should be the heap size? And then to do that, you need to check the Humongous allocations and then set your G1 heap region size manually, okay, to a proper value. So that this problem. In our example, they agreed with us to increase the heap, then we increased. And then the problem is resolved automatically.
Excellent, excellent. Now I understand the specific case. So it is a specific case here. Just two last questions. Can we inject the flags on the fly instead of rebooting the machine? Because, you know, if a customer had downtime or slowness or the availability is critical for the customer, I believe we can set the flags on the fly as in heap dump on full GCs. We don't need to restart the machine at that time. So I'm not sure if these flags can be passed to the process while it is still running.
Are you asking for setting the, for example, G1 heap region size on the fly?
No, only print references, for example, or print adaptive size policy, because we are not going to.
Yeah, I understand. I am not sure. I'm not sure, but I think we are not. I mean, because you define the block size.
All JVM-based options should not be modified on the fly. I could be wrong. If I am wrong, bring evidence, please.
Yeah.
You can basically run a command and then just grep for manageable. It's in a KB article that I just linked, and so they can change between versions. So I wouldn't say it's not there without actually checking against the version.
This one.
Mohammed, this is what you're talking about, right?
Mm-hmm.
So that's JInfo, right? I would
Yes.
imagine this requires a
Yes.
JDK, correct?
That is correct.
Yeah, these are the ones that were present, I think, when this article was written, but it could have changed.
Yeah, okay. So we need to just check and see if we can or not. Maybe we can update the KB article as well, if it is at least for these two parameters, if we can or not.
I also wanted to add
Exactly.
a real life example of what could generate something that's a humongous allocation, and I'll just start off by saying insight, because that does a lot of humongous allocations. And the last one that I specifically saw was that you can instrument data from AWS using it. So like you can pull objects from AWS. And one of the ones that it can pull is CloudFormation templates. So it actually pulls a whole CloudFormation template into memory and then processes that. And it does it all as like one chunk of JSON. And in this case, it was like 100 megabytes of JSON. It actually wasn't the problem. We just happened to see it in a heap dump.
Yeah. Aziz, you were asking something?
Yes, my question is quite simple. Let's say that we did our calculation and we find out that the XMX should be 32 of 33.
Okay.
Can we take this as normal because 33 is not also a good position for the GVM, or shall we go back to 40 something?
I think if you're talking exactly 32 gigabyte, I think better to set it 31 and monitor your replication behavior. If it is still happening, then go over 45.
45. Okay, good.
Have we gone over the reason why 32 is kind of a difficult spot? Right.
Yes. So the last thing that I want to talk about it, of course, we talk about not exceeding having 2048 blocks, and then the block size maximum currently in Java is 32 megabyte. But I checked and I also put a note here, starting from JDK 18, they increase the G1 heap region size from 32 megabyte to almost, not almost, 500 megabyte. So if you multiply this amount with having 2048 blocks, it means that you may have, you may set in the feature of if you have a JDK 18, of course, if you have sufficient physical memory as well, you may have 1 terabyte heap size as well. So it's quite like, I don't know how you are going to have a full GC and how long it's going to take in case.
Will take 3 days.
I don't know. Maybe. Yes, Mohammed.
That's my exact question. So if we raise, so the customer is having an issue. If we raise the heap, just double it to 64, for example, by the calculations, wouldn't be making the environment suffer a little more with full GCs? It was doing full GCs on 32, which is probably 1 second. And now with 64, it might be a little higher. So you get rid of a problem, but now the minor GCs will take longer. Or is it neglectable in this case?
Yes, I mean, it depends. As I said, do you having a 31 gigabyte heap size and having a to try to have a less pause target, but having often, I mean, more often full GCs, or having a larger heap size, a bit more maybe pause, but having less problem. So it depends on pros and cons, you know. But of course,
quickly breaking it down, you've got twice the area for a memory address on a per object basis. So from there, it goes without saying that it depends on how many objects you have and how big these objects are. So if you've got a lot of very small objects, the impact on the heap can be significant. And so the calculation may be a little bit off comparing to what you expect. Would be able to confirm that.
All right. So basically,
can you repeat again? So you are breaking up, Mohammed. Sorry.
I'm sorry. So it's case per case. It depends on what the customer has.
Yes. That's why I mean this. What we learn in this training is not going to applicable to each cases. As I said, we need to approach to the case first to understand what is the problem. If we have an out of memory error, if we have an out of memory error and we can see something in the heap size, it's okay. It's good to see that. But not always an out of memory error is going to help us to understand the issue. Sometimes we need to increase the heap, and then to increase the heap to see that what is the really good size. Because you know that sometimes it happened to me a lot. We ask customer and we say, okay, increase your heap from 16 gigabyte to 20. They say, why 20? I mean, okay, this is really good to understand and then tell them to convince. Also good to show our expertise without saying anything, just how to say, without doing technical analysis.
Without guesswork.
Yes. Any other questions?
Just one question around the Humongous heap allocation messages in the logs and where we see the object sizes. So is there any flags or anything at all that we can do to attribute those objects to, you know, what they could be related to? Obviously, we can, you know, get heap dumps when required and try and figure out what they're associated with. But right off the bat, just on the logs, is there anything that can be done? I'm assuming not, but just wanted to understand if there are any options at all.
I didn't get your question. Sorry, Pankaj.
No, I mean, in the Humongous object allocation messages in the logs, we also see the object sizes, right? That is all we have. So then we look at this object size and then we determine is it half of the region size or not, and then calculate our heap sizes for recommendations accordingly. Now, just to identify, I mean, you know, what this object size is associated with, it could be what object is it associated with. Generally, we might have to get a heap dump to try and understand, you know, what is happening is of out of memory errors and all of that. Exactly. In cases where we don't really have out of memory errors, for example, the other explanation you mentioned was to reduce the heap size. and then, set the flag for a heap dump before out of memory, and then try and see what allocations are happening to get an idea or understanding.
Exactly.
Is there any other possibility where we can, kind of attribute these humongous sizes to any objects at all, apart from what
As far
we
as
just...
I know, you need to make have a heap dump and then go into
Right.
details. The complex analysis needed.
Okay. Yeah.
And then you may need to work with developers as well. So okay.
Because I mean, yeah, we would be increasing the sizes and all of that,
Yes.
but we might still not be able to, answer for sure as to what could have possibly contributed toward this humongous allocations, or where they could be coming from, apart from.
You're right. You're right. I mean, if I was a customer, I would ask. But if I was a smart customer, I would say, okay, it's going to be a lot of work. Like you're now talking about an application, let's say optimization. This is something, if instead of you, the developers, I think this is my opinion, developers themselves, they need to work on their local environment, and before they release their applications, to see that, okay, my let's say application has a humongous allocation, okay, let's tune it. So
Right
now everything is left on us by this comment, so it's not easy, to be honest. I mean,
yeah, certainly. Thank you so much for helping us out with all of these details, and helping us understand how things work internally, and what do we need to look at, and how do we optimize. So thanks for that. Yeah.
Any other questions? Thanks, you too.
I have a question. Presumably there are cases when setting the humongous allocation too high could cause issues. How would we know if that's the case?
So
there are instances of that.
So you ask when to understand if the problem is happening in humongous allocation.
So if we increase the allocation, the humongous allocation, presumably that could also cause memory problems, allocating too much memory to some number of objects. How would we know if that's the case?
What do you
We've set
mean
it too
by
high.
increasing humongous allocation? Sorry, I didn't get that point, because humongous allocation is a problem.
So let me. So if we increase the, sorry, let's see.
The heap size or G1 region size?
So if we increase the G1 humongous allocation,
You mean this parameter?
yes, yes. So if we increase that,
Yes.
presumably that could also cause memory problems. I'm guessing, and tell me if I'm wrong, because if we have a lot of, if we increase it to 15 to 16, whatever, if we have a lot of larger objects that are just at the threshold, then presumably we could be taking up more, we could be allocating more memory to them than we want. Is this, does that make sense? If
No,
it doesn't-
I understand your
Yeah.
question. Actually, maybe to clarify that part. So we increase this one, okay, this G1 heap region size, in order to avoid these humongous allocations, because humongous allocations are causing, how to say, inefficient or unhealthy allocations, because you have blocks, okay, you have blocks in your heap size, and then we allow half of each block to be allocated. This is how JVM works, okay? You are not allowed to, I mean, in a healthy case, I'm talking, make more than half of the block size, okay? So when you actually, that's why we are trying to increase it from the maximum allocations, which are marked as humongous. So when you increase it, you resolve your application problem, okay? But you use more resources, okay? So if your server doesn't have enough physical RAM or physical memory, then it can be a problem. I mean, in terms of, if you're asking what kind of problem we have if we increase G1 heap region size, I can say that you may hit to some limitations, like this G1 heap region size is maximum can be 32 megabyte. And that means that if an object is going to be marked as humongous, if it is more than 16 megabytes. So even you set G1 heap region size manual 32 megabyte, and then another allocation is done, which is more than 16 megabytes, it is going to, you are going to still have humongous allocations. So that's why you need to increase your heap in order to mitigate the issue. You are not going to still resolve it. Okay, so it means that you will have more, you will need more resources. And in such cases, I prefer instead of increasing the heap size, reduce the heap size and see who is allocating these huge allocations in the G1 heap region size. Okay, you can tell the customer, look, okay, we hit to the limit for G1 heap region size. It's 32 megabyte, and in the logs, I still see G1 humongous allocations. So it's not going to help us to increase. I mean, it's going to help, but we are going to use more resources. Let's reduce the heap size and have an out of memory error to understand who is allocating this. So I think this also, this is another case that maybe Pankaj and Mohammed also asked. So as I said, we are always in some limitations that I explained at the beginning of the page, like physical memories, and then the Java itself, it has some algorithms, and then as you see that limited G1 heap region size and so on. So, but actually what you said, increasing G1 heap region size is not going to cause another issue if you are not going to hit the limits, okay?
Yep.
But doesn't it reduce the amount of regions that you have in total?
Sorry, David?
So if you don't change, like, let's say you just adjust the region size to a higher value, then wouldn't by logic dictate that you would have less usable blocks, right?
Yes.
Well,
Yes.
yeah, the bigger the slice, the
Yes.
fewer
You can,
of them in the case.
yes. You can
So you
still
have fewer blocks to allocate that the JVM can allocate into, right?
exactly. Actually, you are reducing your heap size.
That's what I'm getting at. Yeah. So that could be a side effect that you can
Exactly.
reduce the overall available memory for allocation.
Yes. So you will have less block size. Sorry, less number of blocks. So less than the 2048 or which JVM needs. Any other questions?
Yes, if you go back to that GC viewer screenshot that you show us,
Sure.
if you still have it, yeah.
Yeah, I have it.
Yeah, I think here I have two questions. The one is the throughput. When should be worried? It is 95, below 95 should be like a kind of worries that it is not good. That is one. And also the GC performance value. I see a lot of differences between customer, and I never know what will be the good value to just consider it as good.
I think you shouldn't focus on this GC performance because it depends on your heap size. So,
Right, yeah.
So we should consider this. I think the main point here should be the throughput. Based on my experiences, if it is less than 99%, it seems to be a problem for me. Like 98 is also sometimes a problem. So
yeah, in 98%, there's already something off there.
yes, over 99 is always good. Means that you it's like that, Aziz, you say your manager gives you a task and then said that you have 10 problems to solve in 1 minute, okay? Because 1 minute is your target.
Yeah.
And then JVM here, G1 GC defines a target pause time. It says that I don't want to pause or stop other threads to working, and then but at the same time I have to finish all the things that I need to finish. Like you have a room to clean and you have only 1 minute. In that 1 minute you need to finish as much as, like, if you leave some garbage there, it's going to be a problem for the next cycle.
Okay.
So that's why 99 over 99 is always the best.
But what if we have like 95? What is the next step to do in this case?
Problem, then you will see. I mean, 95 means that you will, for sure, if you check your GC logs, you will see a lot of pauses, which is GCs, and it's going to cause a full GC also. For sure, you will see a lot of full GCs there.
Okay, then we consider like analyzing the out of memory error and pressure. Yeah, okay, good.
It may be worth also noting when you look at the throughput, it should be for over what time period as well. Like, of course, seeing a low number is bad, but you may see a higher than expected value if the time span is long and the problem was small.
Yes, this is another case.
Sometimes what I'll do is I'll cut like if we have a time span from the customer, I'll cut the GC log down just to that to get an idea.
Any other questions? Okay. Thank you so much for listening and then also asking really good questions. I hope you find it quite efficient and then, yeah, at least it's going to help you in some cases.
Thank you. Yeah, thank you, Al, for
Yeah.
working on this one. It is a hard topic, but thank you. You make it clear to us. Thank you.
Thank you so much.
Thank you very much. Al.
See you.
Thank
Bye-bye.
you, Sal.
Thanks.
Thank you.
Thanks a lot, Alex. Thank you.
Thanks.
Good day, everyone.
Thank you. Bye bye.